In the summer, the compressor, the heart of the heat pump, receives cool, low-pressure refrigerant vapor. It then pumps this vapor into the high-pressure side of the system. This hot, high-pressure gas now travels through a routing valve known as the reversing valve to the outside coil, which functions as the condenser. In the condenser, the heat is removed from the refrigerant by the outdoor fan, causing the refrigerant to condense into a liquid. The liquid refrigerant now bypasses the first expansion valve by means of a one-direction valve known as a check valve. The refrigerant, now cooler but still under high pressure, travels along the liquid line to the indoor unit, where it is forced through the second expansion valve. This valve partially restricts the flow of refrigerant, creating the needed decrease in pressure, which allows the refrigerant to start evaporating. As the refrigerant evaporates, it absorbs heat from the passing air. In addition, the cold evaporator collects moisture, which provides dehumidification for the home. The refrigerant then travels back to the compressor, where the process is repeated over and over again. During the winter mode, the reversing valve reroutes the refrigerant path, thereby making the outside coil function as the evaporator and the indoor coil as the condenser. The heat is absorbed from the outside air by the evaporator, then brought inside and released by the condenser to heat the home's air. Also notice the outdoor expansion valve is now active as the indoor expansion valve is bypassed. This is a very efficient and cost-effective method for heating the home. There is one inherent problem, however. In order for the evaporator, now outside, to absorb heat, it must operate at temperatures lower than the outside air. This very low operating temperature allows ice or frost to accumulate on the outside of the evaporator. The remedy? The defrost cycle. As the defrost cycle is initiated, the reversing valve switches the refrigerant path back to that of the summer mode. This allows indoor heat to be transferred from the inside airstream to the outside coil, thereby melting the accumulated frost. To speed this process up, outdoor fan operation is terminated throughout the defrost cycle. Also notice that the indoor airstream, now being robbed of its heat, becomes very cold, which is not a desirable condition during winter. To compensate for this condition, the auxiliary heat is activated for the duration of the defrost cycle. After a few minutes, the outdoor coil is frost-free and the defrost cycle is terminated. And that's how a heat pump works.